In this video, we're going to look at combining analytical circle geometry with trig. So just when you thought life couldn't get any more complicated with math, sadly it does, but we'll look for ways to simplify it in this video today. And so prove the radius of this circle will never exceed root 13, where theta is an element of the real number. It's very easy to imagine seeing this in the middle of exam, stress out and think, oh my word, I've never seen trig in an analytical, woe is me, I don't think I can do this. I find it's always best just to start with the basics before you let your heart panic a bit, and just to see where it goes. I will show you some extra tricks along the way, but watch how we just go in with what we know. So if I want the equation of the circle, because that would be a very helpful place to start, getting it in standard form. The tricks we learned earlier is that it's half of the x term, so that will be 2 cos squared. It is half of the y term squared. I'm going to take the 3 across, and then because I magically introduced these in, I'm going to magically make sure that I square it on this side as well. Whatever I've magically introduced, I kind of counter it by doing it on the other side. And so for starters, here's the equation of the circle. If I wanted the center, if that was a question that they're going to ask something about, it would simply just be what comes out of here. It would be negative 2 cos, and the y value at the center would be negative 4 sine. But this question focuses and hinges all to do with the radius, and so I'm going to just focus on this side, which represents the radius squared. So keep that in your mind. This side represents the radius squared. So we've got minus 3. Let's just times this out to see what's happening. Got 4 cos squared x and 16 sine squared x. So at first glance, it looks like a little bit of a headache. One thing that's buzzing in my brain is I'm seeing squares, and I know that if I had a 4 cos squared plus a 4 sine squared, that equals 4. That's all the way back to this simple one that you learned probably in grade 11 or 10. Sine squared plus cos squared is 1. If I had 4 sine squared plus 4 cos squared, the answer would be 4. So I'm going to use that knowledge of identities to split up the 16 sine squared to just being 4 sine squared, so that works well for me, and then I'll just write out the other 12 sine squared. And so 4 cos squared plus 4 sine squared is 4, so it's minus 3 plus 4 is just the number 1 plus 12 sine squared. Another thing that's really helpful at this point is just to think of a normal parent sine graph. So I would always be drawing these in my exam, and you can see how quickly it can take, just literally judging by how quickly I've drawn it, to see it must never exceed 13. So in other words, what's the biggest that this graph could ever go to? And if you have a basic knowledge of trig graphs, you know that sine and cos, the biggest they go to is 1, the smallest is minus 1. So the biggest that this will ever be is 1. And it's squared, so I just square it. And so the biggest that I can ever make this will just be 1 plus 12 in brackets 1 squared, which is 13. So the biggest that the radius squared could ever be is 13. So the biggest that the radius could ever be is root 13. And there we've helped to solve a question that at first glance looked awesomely complicated. I hope this video was helpful. If it was, please like the video, subscribe to our channel, and share this with your friends. Thanks.